Hey everyone, Wes here. In this series, we're going to be building a complete web application from scratch, and we'll be following a practice known as test-driven development. Now, I'm sure you've heard of TDD if you're watching this video. It is essentially the practice of writing tests before we write production code. And this was an idea that was really championed by one of my developer heroes, Kent Beck, along with his ideas about extreme programming. And I believe he described it as a way to essentially manage fear when you're coding. And the idea is that we are going to make assertions about what we would like our code to do before we actually write the implementation in production code to do it. So if you're interested in further reading about this directly from Kent Beck, I would highly recommend checking out his book, Test-Driven Development, which I know is incredibly popular. And others have also written about it. Uncle Bob in The Clean Coder talks about its benefits at length, and I believe there's some of it also in Clean Code by Uncle Bob. It has also been kind of a controversial topic in the past. I know that some people really see a benefit in writing tests before they write code, whereas others say as long as you write your tests, whether it's before or after the code, the important thing is that you really have a way to exercise the production code that you write. But I think that the general consensus among experienced programmers is really that TDD is an excellent practice to adopt for ensuring that you're writing testable, well-designed code. Now, I do want to kind of make a little bit of a distinction here. I think that while TDD is extremely useful as a practice in writing testable code and building designs that you can test, it isn't going to make design decisions for you per se. So while it may be the case that you can write bad code with TDD, I think it's just far less likely. Because in order to test something in code, generally you need to be able to isolate it. You need to be able to assert something about the functionality of a piece of code independent of some particular state, or at least with state controlled in such a way that you can say, given the state of the world is a certain way, then the piece of code that I've written should behave as expected. Whereas if you kind of take an approach of writing tests later, maybe after you've written a lot of code, then there's a chance that you will have written some code throughout that process that's going to be really hard to extract and isolate without calling perhaps many other functions or methods or setting up a whole lot of state just to be able to test what you've written. So for that reason alone, I think TDD is a really good practice to at least learn and maybe practice for yourself and see if you think that it helps you. One of the other benefits of TDD is, of course, the fact that the code that you produce when you are doing TDD is covered by tests. And so you can at any point when you're working on your system run tests that make assertions about the code that you've already written. So in that sense, you can change code and you can extend code with much more confidence than you could otherwise, because if you can actually test and make certain assertions about how your code behaves as a result of having written tests for it as you wrote that code, then I think that's clearly a benefit. You end up with a whole bunch of unit tests, each of which explicitly state the expectations that certain code has. So in a sense, it forms a living documentation for your code base. So as long as those tests are green, then anyone can go into the test suite and take a look through at all of the test methods and get a real sense for what the code is actually doing. And this is going to be far more valuable than static documentation that's written at any point in the software's lifetime. And that's because as long as those tests are passing and the tests are written properly, then you can be certain as a developer that those tests clearly document the working state of the code. Okay, so now I want to talk about the 3 rules of TDD. The first rule is that you're not allowed to write a line of production code before you write a failing test. The second rule is that you're not allowed to write more of a test than is required to fail, and not compiling counts as failing. And then the third rule of TDD is that you are not allowed to write more code than is required to pass the failing test. And so what happens is you go through this loop of writing a failing test, you see the test fail, you read the exception, you see why it fails, and then you write a very small amount of code, just enough to get that test to pass. Once that test passes, you can then go and clean up and reduce duplication, do small incremental refactoring, and then continue on with that cadence. Write another test making an assertion about the system, see it fail, write just enough code to make that test pass, do a small bit of refactoring, and sort of work your way in this cadence through changes to the system. If you've never done this before, it may seem incredibly foreign, and it might feel a little awkward writing a whole bunch of failing tests. It might even feel awkward being in this loop where you're actually executing your code every 30 seconds or so. You're compiling your code if it's a compiled language. You're making sure that it compiles. You're making sure that the functions and methods that you call are returning the types of results that you expect. And effectively you're exercising your code as you're writing it. So rather than spend hours and hours writing code only to uncover maybe a dozen or 24 bugs after several hours of coding and then going back through and trying to fix all of them, you are essentially fixing everything that is immediately broken as you work. And one of the side effects of this is that, as I mentioned earlier, you end up writing code that's really loosely coupled. Because if you want to test the behavior of something, again, you want to test it in isolation. And so it sort of really plugs into a lot of ideas about clean code. Things like dependency inversion come into play here, single responsibility principle, and many other principles. Really, you find yourself really understanding what your code does and writing it in such a way that it's really easy to compose more complex functionality as you build functionality into the system. So we're going to kick things off here. We're going to take a look at the application that we'll be building in this series. We're going to start from scratch, so we're going to write every test from scratch, and we're going to look at the kind of cadence that we can get into when we do TDD, and we'll demonstrate here how it can be used to actually build real-world applications. So I hope you guys enjoy this series. Thanks for watching. If this video series is useful to you, I would really appreciate it if you liked and subscribed. And with that, let's go ahead and get started. Okay, so let's take a look at the application that we'll be building the backend for in this series. We have a named entity finder, and the way this is going to work is we're going to type raw text into our search bar. So Judith Polgar is a Hungarian chess grandmaster from Budapest. And when we select find named entities, we get in response two different visualizations. First, we have the sentence itself parsed, and we can see the named entities highlighted in that sentence. And then we also get a table below with the entity and their particular type. And so we're going to be building the backend for this, where we receive this raw text at an HTTP endpoint, and then we parse it using spaCy, which we'll look at momentarily, and then we serialize that data and send it back to the client so that we can construct this front end. And we'll be doing all of this using a test-driven approach, so we'll look at how we can get into a rhythm with TDD so that we write our tests first, and then we write the minimum amount of code that's required to get our test to pass, and then maybe we do some cleanup, and then effectively we just repeat that process until we have the fully tested features that we would like to spec out for this particular application. So now a quick look at some of the dependencies. Before we start, it would be good to install virtual env, so we'll be using Python. And with virtual env, we're going to be able to scope our project dependencies to this particular project, as opposed to installing the dependencies global for the particular Python interpreter that you have on your computer. So anytime I make a new Python project, I'm typically going to be using virtual env to isolate the dependencies just to that particular project. And so I'll paste links to all the links that we visit here in the description, but you'll need to install virtual env to set up a virtual env for this project. Next, we're going to be writing end-to-end tests as well as unit tests. So with the end-to-end tests, we're going to be doing some browser automation with Selenium. And for that to work, we're going to need to choose a particular browser that we'd like to automate. And for the purposes of this video, I'll be automating Firefox using the Gecko driver. And so head over to the link for Gecko driver to download the latest binary if you'd like to use Firefox for the end-to-end tests. And if you'd prefer to use something like Chrome, then you can pick up Chrome driver as well. Alternatively, either one is definitely going to be compatible with Selenium. Okay, next, I mentioned spaCy. We don't need to download anything here yet. We'll be installing all the Python packages with pip, but I did want to mention the website for spaCy. It'll give you a really great introduction to the library. It's a really powerful, fully featured natural language processing library for Python, and we'll be using it specifically for named entity recognition, but it does much more than that. It's a fully featured natural language processing library, so we can do anything from tokenization and part of speech tagging and build all sorts of interesting natural language processing pipelines. And so it's a really fantastic library. I've used it at various jobs and on personal projects for NLP tasks, and it's the library I would definitely go to use for this type of application. Next, we'll be using Flask, which we'll also install with pip, but I did want to point out the Flask website here if you want to get more experience understanding what Flask can do. We're going to be using it to build a few very simple endpoints. We'll be building a get endpoint and a post endpoint so that we can effectively get the page, serve up some static HTML, and then make post requests in order to post the data to our app, which is then going to serve us back the data we need for our feature here. And just to try out another few things here, just to demonstrate that it works for sort of arbitrary text that we input. Mumbai is on the west coast of India, and so it does a pretty good job in general with the language model that's loaded for our purposes here of identifying named entities. So this should be a lot of fun. All right, so let's go ahead and get started. The first thing that we need to do is make a new directory for our project, and I'm going to call this directory Flask NER, and then we're going to move into that directory, and it'll be here that we create our Python virtual environment. So we can run that with the command virtual env env-p python 3, and so that's going to create a new Python 3 virtual environment in this directory. Now we can activate it by running the command source and then pointing to env/bin/activate. And now we're ready to install our dependencies. So we'll pip install spaCy, Selenium, PyTest, and Flask. And this will just take a few seconds. Once this is complete, we're going to run a script python-m spaCy download encore web small. So this is going to be the small language model, the small English language model that is for spaCy, and it'll be the language model that we're using for our app. So you can see that we'll get a message here that we can now load the model via spaCy.load encore web small, and we'll take a look at that when we actually start writing some code. The next thing that I'd like to do is to create a directory structure. So right now we just have our env virtual environment directory. So we'll make a few directories here. Static will be used to serve up our JavaScript and CSS. Templates will be used to serve up our index.html Flask template. And then test will be where our unit tests and end-to-end tests are located. Finally, we're going to edit a new file called setup.py. And this is going to allow us to actually install our current directory as a package. So from distutils.core, import setup. From setup tools, import find packages. And then here we just need to call setup, and we're just going to pass it a few arguments. The name of our app, which we can call Flask NER, the version, which I'll say is 0.0.1, and a description, a simple NER API. Okay, so we'll save this file, and then we'll run the command pip install-e dot to install this directory as a package. And -e means editable, so we'll actually be able to edit the code in this directory, and it will continue to be treated as a package without needing to sort of reinstall it, if you will. So let's start our TDD approach here with some unit tests. So I'm going to move into the test directory here, and in any editor of your choice, just go ahead and open up a new file we're going to create called test-ner-client.py. So here we're going to import unit test That'll be the library that we're using for our test runner. And we're going to create a new class called test_NER_client, which extends unittest.testCase. And then when we write our unit tests, they'll just be methods on this class. And this class is an instance of a unit test test case base class. And so this provides us some helper methods that we can use to do things like make assertions. So let's think about the business logic here that we want to exist. So we don't have any code yet whatsoever, and we're inside of a test here. So we need to think about the behavior of this NER client object that we're going to use to extract some named entities. So the way I'm thinking about it is that we will have this object, which maybe has a method on it that receives a string as input, and as output it's going to return some type of data structure that contains our named entities and the sentence, for instance, however that's going to be represented. So we're going to write a new test here, and we're going to sort of make, just to get warmed up, maybe the simplest type of assertion we might make about such a client and its behavior. So let's imagine that we give this thing an empty string. We would still want it to return that data structure, and maybe it just doesn't have any data on it. So let's just imagine that this data structure is a dictionary, and so our test might be some method getEnts returns a dictionary given an empty string as input. So nothing more or less than that, but we're going to code by wishful thinking in the sense that we're going to imagine that we had something called a named entity client, and we were able to get some entities from it by calling ner.getEnts, for instance. And in this case, we're going to pass it an empty string. I'll call it string. And then we're at least going to assert that what we get back here is a dictionary. So we can say self.assert is instance, ents, which is our result that we get back, and the Python type is dict. So right now, I'm kind of imagining a structure that looks something like this. Just a Python dictionary, which has two keys on it, ents and HTML. And ents is just some list of another dictionary perhaps, or maybe an object type, which has some properties on it like the type of named entity and the text for the named entity. And then the other key in our dictionary will be the HTML that we can output to our client to do the labeling of the named entities in sentence format. And we'll do it like this because I know spaCy has the ability to give us HTML like that, and so we might as well leverage the ability that we have with spaCy to do that. The entities, or the ents key here, which contains a serialized list of ents as we would like to display them for our table, will be useful as well. So we'll imagine a structure like this getting returned from ents, and so we'll keep this in mind as we think about how we might want to build the behavior for this NER client. Okay, so all we have to do now is we want to run this test, and I'll be running the tests within Vim using a plugin. I'll put a link in the description if you're a Vim user and are interested in unit testing in Vim that makes it really easy. I can hit my leader key and then another key on the keyboard and just run the current test under the cursor, which you can see is currently failing. But if you're just working from the terminal, we can come back here, and what you can do is run python-m pytest, and this will also search, I believe, recursively through the directory and find all the unit tests. So either works. So right now, as you saw, the test is failing, so let's examine it. So as we do TDD, when we write our tests are going to fail initially, and they're going to give us clues, if you will, about what we need to do to move forward. And so here we see we have a name error that named entity client is not defined. Well, that's true. We haven't made it yet. So let's go ahead and make it. So what I'm going to do is, I'm in the test directory now, so up a directory, I'm just going to create an nerclient.py. So the directory structure should look something like this. NER client is just in the root of our project directory. And here we'll have a single class named entity client, which we need to initialize. And we don't really know what else we need to do yet, so we're just solving one step at a time. If we head back to our tests, we should now be able to, from NER client, import named entity client, and we run our test. we'll see that we're failing for a new reason now, which is that named entity client object has no attribute getEnts. So let's go ahead and fix that. Def getEnts, which we know takes a string input, so we'll just call this sentence, and we're asserting that it returns a dictionary. So let's start with the smallest amount of code that gets our test passing, and we'll head back. And now if we run our test, we can see that it's passing. So this clearly isn't the behavior that we ultimately want, but it's enough code to get green for a given test. And so we're simply making an assertion that our getEnts method returns a dictionary. And so the simplest amount of code to actually do that is what we have here. getEnts takes in a string, sentence, and returns a dictionary. So we're going to have to write more tests to explicitly test more behavior than this. And our test should always pass because the assertions that we're making about the behavior of our code don't change. So let's imagine a very similar test. That test getEnts returns a list given non-empty string. So we're going to have our named entity client again. We'll grab our ents, and if we pass a sentence this time, a non-empty string, Madison is a city in Wisconsin. And actually, if we run this test, we'll see that it also passes. So right now our code doesn't distinguish between whether or not there's an empty string or there is a string. In both cases, it's returning an instance of a dictionary. Okay, so let's start thinking about some more concrete behavior than just whether or not it returns a particular Python type. So really, what we need to do here is to think about the behavior of this class. Our tests are going to help us actually explore what the behavior of our class is through assertions, but we need to be very precise, if you will, about the behavior that we're making assertions about. So we have to keep in mind that we're not in control in this particular application with developing the statistical language model that's being used to present us with named entities, to do that extraction for us. If we were, say, building a custom model, which we could do with spaCy, then we might need to make assertions about the fact that it maybe extracts things like Madison every time or Wisconsin every time from this string. But rather than make assertions about the behavior of the statistical model, which we just downloaded, we need to make assertions about the behavior of our object, the NER client, named entity client, and the structure and content of the results that our named entity client presents us with, given its dependency, which is spaCy, gives us something in the first place. So we're not trying to test spaCy here, we're trying to test our NER client. And so the way we need to think about this is given spaCy gives us A, then we expect B to be some condition that's met as a result of its use in our object. So I just mentioned that spaCy is a dependency of our named entity client, and that's true. And when we think about dependencies, something pops into our mind here, which is the dependency inversion principle. So we could do something like this. We could have a named entity client. If we come back to our named entity client here, we know that we're going to need spaCy, so we could import it here. And then here we could do something like self.model is equal to spaCy.load in core web small. And with spaCy, this returns us a callable that we can pass a string to get a document back. And then here we could do something like doc is equal to self.model, and we could pass it sentence. And then we could work through to extract the named entities from this doc, which is something that spaCy is going to help us with. But here we're tightly coupled to spaCy existing in the first place, and anytime we create an instance of a named entity client, we're going to be loading this language model into memory, or at least having a reference to it in the client here. And if we're testing the behavior of this client, we don't really want to have to load this external statistical language model every single time that we new up an instance of named entity client to test it. And furthermore, we may wish to use different models, maybe not even use spaCy altogether. And so one of the ways that we can accomplish that is through exercising the dependency inversion principle from Solid. So the idea is that rather than have named entity client depend on some detail, which is this model, it should instead depend on an abstraction that gets passed to it. And so instead we can pass model here. We'll say self.model is equal to model. And in fact, the code in the method still acts the same. It's just acting on the instance model that's on named entity client, but rather than named entity client being in charge of instantiating that model, we pass it from a higher level of abstraction wherever we're collaborating with named entity client. So we're not going to write any code just yet. We're still going to return dictionary, except the way that we construct named entity client with this new parameter in the initializer will be a little bit different. So now we know that our named entity client needs to take some model to get constructed. And to test this, we need something to stand in place of the spaCy NER model. So we might have an NER model test double. This is where you hear about things like mocks and spies and other types of test doubles. We're not going to write out a full mock of the actual NER model provided by spaCy, but we do need to know a little bit about how it works to create a lightweight test double that can stand in for the behavior of the real spaCy model in production. So when we're testing, we just need something that behaves in a way that we can control, that behaves like the spaCy model, but doesn't load this entire language model every time that we create a new instance of our class. Rather, it just behaves in such a way that we can say things like, given spaCy returns a named entity collection on the spaCy side for something like this particular string, then our named entity client parses that result from spaCy correctly and puts it into a format and a structure in such a way that it's responsible for, that we can work with. And we can make assertions about that, certainly. Okay, so if we run our first test now, we're going to fail because NER model test double is not defined. So let's go ahead and define it. I'm going to create a new file called test doubles in our test directory. And we'll make this class NER model test double. And in order to make this, we should look at how spaCy actually works. So what I'm going to do is I'm going to move into our Flask NER directory. We're going to source env bin activate, and then I'm just going to start a Python REPL here. And so we'll import spaCy. And then typically what we do with spaCy is we do something like this. We say something like NLP is equal to spaCy.load, and then we load in that model that we downloaded. So we downloaded the English Core Web Small, I think. And then we say doc is equal to NLP, and you can see NLP is a callable. So spaCy.load is returning us some Python callable, whatever it is, and we provide it with something like Madison is a city in Wisconsin. This in turn returns us a spaCy doc. So if we do type of doc, we can see that this is a spaCy tokens doc class instance. And this doc has ents on it under ents. So we can see Madison and Wisconsin. And each of these ents themselves have some additional properties. And so here we can see also that ents themselves contain some additional data. So we can say something like ent.text, ent.label underscore, and I'll mind the typo here, for ent in doc.ents. And so here we can see that spaCy has all this metadata about the various things that it extracts here. It's incredibly useful. And what we need to do now is to create a test double that can stand in place of the actual dependency we have in our client. So we need to create a mock, if you will, for NLP here, and then be able to set the behavior on the doc such that we can control what the ents look like, because we're going to be passing arbitrary strings as users to this callable that we get back, which adds a little bit of complexity to the double for sure. But we are then going to be getting some doc.ents given some string, and those ints, the crucial point here is that we don't know dynamically when we're writing tests what a user is going to type in here, right? So we don't know what the contents of doc.ents is, but we do know something about the structure. We do know that there are a limited number of labels that spaCy can provide us with, and we know that the structure has certain properties on it. The doc class has certain properties on it. It's got text, label, it's got start and end cars, it's got some other things on it that we can make use of, but we're going to create a test double that behaves in such a way that's useful for us to make assertions about the behavior of our class. So let's keep that in mind, the structure, and I'll leave this here just so we can kind of see what spaCy actually does and how we can mimic that in our test double. So I can see that when NLP is initialized, it's initialized with some model, but what's important is that when we create this, we get back a callable, which in this case is called NLP, and we call that with a string. So for our model test double, what I'm going to do is I'm just going to create an initializer here, which we can pass it a name for a model, and we can set it. This part doesn't really matter too much, but when we call it, we want it to return this doc type, so this spaCy doc type. And we can create our own test double for a doc as well, but the key point is we're going to return a doc test double here, so that's what we'll do. And we're going to pass this a sentence, and we're going to pass it self.ents because that's what we want to control. I'm just going to change the panes here to make it a little bit easier to read. So let's look at how we can control this. I'm going to create a method on our NER model test double called returns.ents, which just takes in some entities, and what we're going to do is we're just going to set that on the model instance. Now when we return a doc test double, we're going to set the entities for that doc on it straight away. So this is going to allow us to do a typical sort of mock setup syntax where we can say our test model is a new instance of an NER model test double, and it returns some controlled set of doc.ents. And as long as the interface, if you will, we don't have strict interfaces in Python being a dynamically typed language, obviously, but as long as we write our test to sufficiently conform to the interface of the aspects of this model that we're using, namely that the ents take the same structure, then we can actually test the behavior as if it was spaCy under the hood, providing us with the same type of structure. So let's make our doc test double. This is a test double for a spaCy doc. So it's going to take in sent and ents. And we can see the structure of spaCy ents here. So let's just go ahead and replicate it. Ents is going to be some object. This is actually called a span in spaCy. So what we'll have is a span test double, and I promise that'll be the last test double. That's going to get the ent text, and then ent label for ent in ents. So really all we're doing here now is we're setting self.ents on the doc to this list of spans which have the text and label on them. And in fact, this should be label underscore. As we can see, that's the format that spaCy uses. So we're just replicating what spaCy would do, except we're saying we want to be able to set this because we want to say, given spaCy has this behavior, we're going to make an assertion about what we do with it. So the last thing that we really need to do now is to say class span test double, which itself just takes a text and a label and sets self.text to text and self.label to label. Okay, so this is about as lightweight of a test double as we can get away with, and I think that is really a good way to start. I mean, the other thing that we could do here is we could bring in an external library, something like PyTest mock, and or just monkey patch the methods on these classes of our dependencies. But I really like the control we have here. The one thing to keep in mind that's a little bit of a trade-off is that we have to be very careful that the doubles that we create are true stand-ins, at least as far as their scope to the methods that we're using here. They're true stand-ins for the way that our dependency actually behaves. So just some thoughts to keep in mind. I really like doing it this way. You can see in less than 30 lines of code here, we have a useful stand-in test double, and we can still exercise inversion of control. Okay, I'm going to close our REPL here. Oops, and we have a typo here that we should fix. We need to use list comprehension properly. So I think that's correct. Span test double, which takes in the text and the label for ent in ents. While we're here, I'll also show you a trick if you want to patch a method in place. We may not need to use that here, but I wanted to show it because it's something that I think can be useful if you're building your own test doubles here. Is a lot of times I'll create a patch method on a class whose method I want to patch, and then I do a nested function here just to return whatever some return value is, and then just set attr on the particular name of the method that we want to patch. We pass that as a string, and then we set this patch to the return value that we want, and then we return self. So this is nice because you can imagine a case where the test double that you're using in place of a real dependency calls a particular method. And here, if we patch the method in place and control its return value, we can hold that constant to some return value and then make assertions like, given some particular method on this dependency returns a value, then we can do a test that way. In this case, for our purposes, we're actually just patching the attribute ents, which is just like a field on the instance, and so we don't need to patch the method call, but we can do that as well. So I just wanted to throw that in here. We'll head back into our NER client, or rather the test for our NER client. And so we have our model. We need to bring that into play here. So from test doubles, import NER model test double. And then here we can say model.returns.ents. And let's imagine that it just returns an empty list. And so we're not really testing just that it's given an empty string, but what we can say is that given an empty string causes empty spacey docents, or empty string. And so if we run this test now, we're passing again. This test will be failing because model is not defined, so we'll bring in our model. And look what happens if we don't set the return for the docents. And we'll say model returns docents empty list. And what we're testing here is test get ents returns, and I said dictionary, or list here, this should be dictionary, given non-empty string causes empty spacey docents. Okay, so this is the case where we pass it an actual string, and we're setting it up such that the natural language model doesn't return us any ents for that string, that we get back a type of dictionary. Okay, so now let's write something a little bit more interesting that we would like to see before we continue writing code for our client. Here we might say something like test get ents given spacey person is returned, which is one of the spacey types. This serializes to person, which is the type that we would like to return with a different spelling here in this case. So we want it to be more human readable than these sort of label tags that spacey returns. So given we have some model, we're going to say that that model returns docents. It looks something like this. We'll say docents as a variable here to make it a little bit cleaner. So spaCy is going to give us, in some cases, something like this. Text and a name of an entity here. So I'll stick with chess players, and we'll go with Laurent Fressinet, who's a strong French chess player. And it's going to return us a label that says person in all caps. So then we're going to create an instance of our named entity client with the model that we've prepared. Doesn't matter what we pass it, ner.getInts. But we're saying, given that we pass it some string, doesn't matter what the string is. If spaCy tells us that the named ents in the string you pass it are this, then our expected result is completely under our control. So what do we want to see here? Well, I don't really want to see text, and I don't really want to see label underscore with a capitalized string person. What we want to see is maybe something like this. We talked about previously. It's up here. So our expected result is to be a dictionary. So let's fix that. It's going to be ents here. This is a list. Of dictionaries which say ent, and it would say Laurent Fressinet, and we just want it to say label with no underscore person. And then we want a second key in our dictionary, which is HTML, and it has some HTML in here, so we don't really know what that looks like yet. So let's make an assertion about the ents on the expected result here. So let's say that we need to assert list equal that the ents that we get back, which is going to be on the key ents, is equal to our expected result ents. And so maybe we'll call this result to make it a little bit more clear. So we're saying the ents key on the result object that we get back, the result dictionary that we get back, should equal the expected result, and specifically the expected result ents key that we've set up here. So given some docents that look like this that we get back from spaCy, our client should behave in such a way that it returns to us a structure that looks like this. And we don't know what the HTML looks like yet, so we're just going to test for the ents key value at this time. So let's run the test. We'll see it fail. We can see HTML is not defined, so that's a syntax error. That's not the type of error that you want. All right, so we'll try again. Key error ents. Okay, so we're getting a key error because result that we're getting back doesn't have an ents key on it. So let's fix that. So now we finally go back into our code and we'll add a key ents. It's an empty list for now, and while we're in here we'll add the key HTML, which will just be a string. Alright, so let's run our test, and now we can see that our lists differ. So empty list is not equal to our list with Laurent Fressinet and a label of person on it. So let's add some code to make this test pass. We're going to come back into our NER client, and so we have our model. Let's use it to get those ents off of it. So we're going to say our doc is self.model.sent, or we pass it sent rather. This is how we use spaCy. So we saw this a moment ago at the REPL. And so the entities that we get back here take this form. Ent is ent.text from spaCy. Label will be ent.label underscore from spaCy for ent in doc.ents. And then ents will be entities, and HTML is still empty string. So let's head back to our test, and we run our test, Oops, and we need to make sure that this is a colon here. Okay, so we'll head back to our test, and we'll run our test. Now we can see sent is not defined. So where we have getInts, so we have another error here. So this should be sentence. Head back to the test, and we run our test. Now we can see something very interesting. So we're still getting back just person in all caps rather than person, which is what we would like to see. So we're using the spacey tag here, and we want to use our own custom tag that we map to. So let's write the minimum amount of code that's required to fix this problem. So what we want to do here is we really want to map this. So let's create a method map label or something. And it can be a static method. We're going to have some label map, which is a dictionary. And so given some spacey label here, like person, we just want to return person. All right, so that's the minimum amount of code required. So now we can return label map.get label. Okay, so if we go back to our test, and we run our test again, we can see that it passes. So you can see now how we're building the behavior of our named entity client by making assertions about its behavior. And so it's not as if when we're doing test-driven development that the tests are really driving the decisions that we're making about the implementations, but what they do is they help keep us focused, I think, on the goal of the assertions that we're saying our code should do. And while it does help sort of shape, I would say, the type of code that you write, the tests aren't going to make sort of architectural decisions, if you will. They're not going to make decisions necessarily about how your objects collaborate, for instance. So for instance, we could have made our named entity client not depend on, not use the dependency inversion principle by passing a model into it, but just creating a new instance of it inside of the class. That, for one thing, would have made it much more complex to write unit tests for, but it also would have made it depend on spacey itself. And as you can see here, this just depends on something that behaves like spacey. And so that's sort of the general idea here. So I'm going to move through the following tests relatively quickly, and we'll just see how we can continue to extend the behavior of the class we're doing. So we want to say test get ints given spacey. Say norp is one of the spacey tags. We're going to resolve this to group. So we'll just make up something here. We want this to be Lithuanian with a label of group. And if we're going to run this again, now we can say label none is not equal to group. So clearly what we need to do is we need to go back to our NER client and add a mapping for norp to be group. Need to put a comma here. We'll go back to our test and run it, and we can see that it passes. I can also run all the tests with capital T with the Vim test plugin that I'm using. Alright, so we could do this for all of the mappings that we want, so I'm going to do that really quickly here. We want spacey loc, resolve to location. We'll run the test, we'll see it fail, go back to NER client, loc would be location. Go back to the test and we run everything and everything's passing. And so if you're kind of in the flow of things, we can make some decisions here. We don't have to just rigidly follow, I would say, this cadence, especially when it comes to maybe just like updating a simple mapping here. So what I'm going to do is I'm going to add a few more here. So given spacey language, this resolves to language. And we're not going to see every test fail here. We'll put in American Sign Language here, and then int ASL label language. Just going to put 2 more labels in here. There's a spacey label GPE, which I believe stands for geopolitical entity. We're just going to say this is location again, just for an example. And so if you did want to see all of them fail, a few of them will fail here, 2 of them. So we'll add our mappings. I'll run all the tests again. Go back to our tests. And we'll run all the tests again. Yep, and we're still failing on language. That's interesting. So let's go back to our mapping. And I can see that I have a typo here, language. So this is another reason I'm actually pretty glad that this happened, because this just demonstrates that if you are doing TDD, or at the very least if you're writing unit tests, you will find the typos that you make here. If you have an IDE that shows you typos, then you can make the argument that you may find it then too. But this is going to show you a big red error that something is not correct. And so just another reason I love TDD as a workflow for particularly starting new applications. It's going to find those mistakes for you and sort of direct your attention to the right place. Okay, so our tests are passing. I'm going to write one more test here, which is we want to make sure that it serializes multiple correctly. So test get ints given multiple ints serializes all. So we'll say that docx returns this one, and say the text comes back as Edith Polgar, label person. What we would expect to get back is analogous. Alright, so let's clean this up a bit. And we'll run all of our tests again. Okay, so we have 8 passing tests here. We could continue to make assertions about the HTML piece. I'll leave it to you to do that, because right now I'd like to move on to doing some automated browser testing. So we'll be doing our end-to-end tests now. So right now we have made an object that is fully tested, consumes actually consumes spacey potentially as a dependency, and parses the results that we get back and can provide them in this sort of dictionary format that we have. But we don't have an API. So let's go ahead and write some end-to-end tests for accessing that API. Okay, so in our test directory, I'm going to create a new file in here called test e2e index, or test index e2e maybe. Test index e2e end-to-end.py. Alright, we're still going to use unit test as our test runner, so we'll import this. And this time we're going to, from Selenium, import WebDriver. WebDriver is going to be what we use to actually automate our Firefox instance in this case. If you're using Chrome, it'll do the same. So we'll say class e2e tests, again extends unit test dot test case. And you can see that test case, just to give you some additional documentation here, is a class whose instances are single test cases. Okay, the other thing that we're going to do here that we didn't do with our unit test is take advantage of 2 test hooks here, setup and tear down. And keep in mind they need to be camel case here. So when we start an end-to-end test, we're going to create an instance of the Firefox browser, and then when the test is complete, we want to close the browser so we don't just have a whole bunch of resources tied up with these open Firefox browsers. So we're going to set a driver on the instance equal to WebDriver dot, and you can see there's a number of different options here. You could use Chrome or even BlackBerry for some reason, or Android, but here we're going to use Firefox. And here we just need to pass a parameter executable path. And this is why I mentioned it was important to keep in mind where that Gecko driver or Chrome driver is located on your machine. Mine's in application/Gecko driver. So it should just be an executable or some other type of binary. And we're going to call self.driver.get, and we're going to go to the root path of our API. And so by default, Flask is going to serve up an app on port 5000, so we're just going to go to HTTP localhost port 5000. And then tear down, we're going to self.driver.quit. Now keep in mind that we don't necessarily need to host our app on localhost. If this were a production end-to-end testing system, then we might deploy the app to a staging environment, in which case we could still run these tests from any machine and hit that staging environment. So that's just something to keep in mind that is potentially useful. Alright, so we're going to start the API portion of our app, and we're going to do this as well in a test-driven format. We're just going to be using these end-to-end tests as the tests that drive our development. So let's make an assertion about what happens when we open a browser and head to the root of our application. One of the easiest things we could do is that we could test that the title in the browser contains our app name. So we could say test browser title contains app name, and we could say something like assert in named entity and then self.driver.title. Oops, and I need to fix a typo in executable path. So now if we run this, it might seem kind of silly, of course, but what's going to happen is our browser is going to open up and we're going to go to port 5000. There's not going to be anything running on it, obviously, and our test is going to fail before anything even happens because it reached an error page. And so when this happens, a WebDriver exception is thrown, and we're actually just going to manually close this. We could do more sufficient error handling to close the browser in this case as well. But we don't have an API running. So the first step is to write the minimum amount of code possible to get something running in the browser so that when we hit port 5000, we have the title named entity happening. So what I'm going to do is in the root of the project here, where our NER client is, I'm going to create a new file called app.py. And we're going to import Flask, or we'll say from Flask, import Flask. We're going to import render template, and we're going to import request. And then we're going to set app equal to a new instance of the Flask object. Just the name of the file gets passed. And then we're going to create our first app route. So we'll say app.route. And then when we go to the root route, in other words, just /, we'll have an index action here. And we're going to return render template with an index.html static page. In our case, it'll be static, except for some JavaScript that's used to do things like show our table and modify the DOM. I'll place a link to the JavaScript in the description of this video. We won't go through writing the JavaScript in this video, as we're just focusing on the back end, but I may make another video in the future about TDD for this specific file in vanilla.js. So now we need to create this index.html. So I'm going to save this file. And then in our templates directory, we're going to create that index.html file. And remember, minimum amount of code to get things passing. The worst thing would be to leave your project in a state where the tests aren't passing. So if anyone comes along and picks it up, at least the tests are passing. You might not have the right solution in place yet, but no one has to go back and fix any broken tests. So that's good. So we'll create a title here named Entity Finder title. Okay, so that's probably the minimum amount of reasonable code for us to write. And then the last thing that we want to do here is say if name equals main, then we want to run our application. And we can do that in Flash just by calling app.run, and we're going to pass it debug equals true here as well, so we can run it in debug mode. Okay, so that should work. We need to actually run it now, so in a new terminal here, make sure you run source-env bin activate, of course, and then run python app.py. This should start your application on port 5000. If that's complete, we can head back to our tests, and we can try to run our first end-to-end test. Okay, so it ran, the browser closed, and we can see that the test passed. So Selenium is going to drive the browser pretty quickly, which is good. We don't have to spend a lot of time doing manual testing, but it's also not always going to be clear what's happening visually. So we need to make sure that the assertions and things that we have in here are clear to other developers and testers coming along. So let's write some more tests. We can say test page title is named, or rather the test the page heading, I should say, is named entity finder. So here we can use Selenium to actually find elements on the page using CSS selectors. So if we have some heading, let's say, we can say self.driver.find element by ID. We can also find element by CSS selector, which I like to do because we can use CSS selectors. Now, if we were to find by ID, this actually brings up a good point. If we take a look at the index.html, so I'll save this, go to index.html, and we're clearly going to do something like this. We're going to have a body. We know that we shouldn't be writing code before we write tests, but I think you get the idea here. We might have some ID that's a heading here. Okay, so we have an h1 tag like this. We've got an ID on it. Now, when we're doing our end-to-end test, we can select any element in the DOM by using things like any CSS selectors, but we might choose to use the ID because that should uniquely identify the DOM node. But the other thing to keep in mind here is that there may be people working on the front end of this application who are making decisions about things like the name of the ID here, or other CSS selectors that we don't want to depend on when we're writing our end-to-end tests. Because someone might come in here and change it to say app heading, being completely unaware of the end-to-end test that we have in place, which we're dependent upon finding an element with this ID instead. So a useful way to get around this is to make use of data attributes. So a lot of times what I like to do is to create one called data test ID. Now when a front-end developer comes in and sees this, and hopefully we communicate with the entire team about the reasoning for doing this, but we would say, hey, we have this data test ID, don't mess with this, do whatever you want with the IDs, but don't change what I have in data test ID because we're explicitly using this as the attribute that we're selecting on when we do our end-to-end tests. And so this gives everyone else the freedom to update the other attributes on the different DOM nodes and makes it explicit that we use this when trying to select it for the purposes of Selenium in this case, or Cypress, which is another really fantastic end-to-end testing suite. Okay, so now we have this data test ID, the identity finder. So rather than find element by ID, we're going to do find element by CSS selector. And then the CSS selector for a custom attribute or for any attribute is just square brackets, and ours is data test ID is equal to, and we're using an F string here to interpolate some value. So I'm going to clean up the quotes here. And then what I like to do as well is just create helper methods throughout this because we're going to be using them over and over again. And so we'll say something like input element is well, effectively this. And we'll interpolate this value in place. And then now we can just say self.find heading, and we're finding our data test ID. So then we can self.assert equal, and we can say that the heading on our page is named entity finder. All right, so let's run this test. And we saw it flash pretty quickly. Ooh, assert that named entity finder is not equal to none. It looks like it didn't find our heading, so let's go back to index.html. Data test ID should be the name of the attribute. Oh, and clearly I just need to return this. Sorry about that. So let's try again. Okay, and this is getting the Selenium object, so forgot one more thing here. We can call .text to get the HTML text from it. So let's try one last time here. And now we can see the test is passing. All right, so let's think about another feature that we might want. Well, we want a way to input some text. So we can say test page has input for text. We'll imagine that we have some input element, self.find, something like, I don't know, index text. Something like input text. And then we can assert is not none. Input element. We would run this. We would see it fail, and it could say it couldn't find, and we can see that it says it's unable to find the locate, and we can see that it's unable to locate the element, so now we need to go add that element to the DOM. We'll add our data test ID again. And I'm going to be using Bootstrap for this, so we'll add a form control here as well, just to anticipate that. So we'll run our test again, and we should see it pass. Okay, so let's write a few more tests here. We'll test the page has a button for submitting text. If we ran this, we would see the test fail. So I'm just going to go ahead and add the button now. And we'll run our test. Oops, and this needs to be not none. So we'll run the test, and we should see it pass. Okay, so let's do something a little bit more interesting here. Let's assert that we want to be able to write some text into the input box and then click the button, and this should generate a table for us. So we're going to write test submitting sentence creates a table for us, and here we're going to get our input element, and we're going to get our submit button, and you can see how we might want to extract these into some class that is reusable. but for now, we'll just reuse these. We can call send keys on the input element. So if we say send keys, and then we say something like, I don't know, France and Germany border each other, or share a border in Europe, and then on the submit button element, we can just call click. And then we can say we have some table which we should find at NER table. And then we can assert as not none table. Alright, so if we run this, we're going to fail for a different reason this time. And that's because we don't actually have the JavaScript to handle that click event to then hit our backend API, which will generate our table for us. So what we can do is, well, it'll say unable to locate the element. So let's actually go set up the HTML so that that element exists in the first place, and then we'll incorporate the vanilla JS script, which will append elements and handle the fetch request to an API endpoint, which we need to make. So here we have some table. We've got a heading for entity and a heading for type. And then for now, an empty t-body. Okay, so the other thing that I want to do here is I want to bring in the JavaScript file that is responsible for hitting our endpoint and handling the on-click events that's on the button here, and then handling the DOM updates as well. So I've just copied that file in here. So it's a JavaScript file, and I'll paste a link to the repo where you can pull this file. It's pretty minimal. It just does a little bit of DOM manipulation and invokes the fetch API to an endpoint that is expected to be running on our application at /NER. It's going to accept a post request, and it's going to attempt to get those results back from us. And so it's going to actually use or invoke NER client at that endpoint. So we'll need to make sure that that actually works. So if we run this test, it actually passes, and it's sort of like our test is named incorrectly here, because it's not that submitting the sentence creates the table, but the table already exists. So we can say page has NER table on it. Now for something slightly different, we'll look at how we can test drive some integration tests here to actually build out the post endpoint that our NER client will be used in. So what I'm going to do is, in our test directory, I'm going to create a new test module called testapi.py. And we're going to import unit test as usual. We're also going to import JSON, and from Flask we're going to import request. Then from app, which is our app, we're just going to import app. We'll make our class testapi with unittest.testcase. So this is all standard stuff, but now we want to make some assertions about the NER endpoint. So we need to make a post request at /NER. So let's test that our NER endpoint, given some JSON body, let's say, returns a 200. So we're using a post endpoint here, and if we're thinking in RESTful terms, sometimes that would be like a create of a resource, and then so a lot of times you get a 201 or another 200 to describe that something's actually happening. We're just going to return a generic sort of success response here. And the way that we can set this up with Flask is Flask provides a nice method on app called testClient. So we can actually say with app.testClient as client, we can make a post request. So let's say our response is equal to client.post at, we're going to test by wishful thinking here and imagine that we have an NER endpoint with some JSON we're going to post a sentence. This is what we would like to be able to post. And we can post a sentence here. Steve Malkmus is in a good band. Then we want to assert that the status code on the response, so this is underscore status code in the case of Flask, is equal to 200. So let's see what happens when we run this test. Well, the name res is not defined because I called it response, so let's try again. And so now we're actually seeing that 404 is not equal to 200, so it didn't find this endpoint. So the easiest thing we can do here is go back to our app, actually, app.py, and create a new endpoint for it. So we'll say app.route/ner, and we'll call this endpoint getNameDents. And the data, since we're posting JSON, we can just get off of the request, so we can say request get JSON. For this, we need to make sure that we've imported requests from Flask. And then we'll just return json.dumps some response. So what does the response look like? Well, we don't know yet. Let's just return true. Okay, so if we come back to our test API and we run our test again, now 405 method not allowed. So that's interesting. We need to update app.py to make this a post endpoint, and we do that with methods equals a list and with one endpoint or one verb here, post. Let's go back to test API and we'll run again. Okay, JSON is not defined. And Steve Malkmus' name is spelled incorrectly. So here we just need to import JSON. And run our test. And now we can see our test passes. So now we have an endpoint that returns a 200 when we post some data with it. In this case, with something about Steve Malkmus in it. All right, so now we're going to write another test. And this is going to be basically an integration test. I mean, we're going to actually invoke our class, and we could write a test to mock out the dependency of our test client and sort of test this like it was a controller test, for instance. But I'd like to move ahead and just do a real integration test with spaCy involved. And so given some sentence, whatever it is, let's make it so that we'll craft a sentence that we know spaCy's NER will actually return some named entities for us, and we'll make an assertion about it. This will be useful. So we'll say test NER endpoint given JSON body with known entities returns entity result in response. Okay, so now we will again say with app test client, and we could pull this out into a test fixture, but seeing as we're not going to get much more involved in this, this is fine for now. Okay, so we've got our response where we're posting to NER with some sentence. We're going to get the data back from that response, hopefully. I'll say json.loads, and here we can actually call response.getData. And we can make an assertion. We can say something like assert data entities, and maybe length of data entities is greater than 0. And so we'll run this test. And so now we get an error that a bool object is not subscriptable. And that's because in our current implementation, we're always just returning true. So we want to actually wire this up now. So what I'd like to do here is we're going to import spaCy, and then from our NER client, we're going to import our named entity client. And then here, which is our sort of composition route in terms of the dependency inversion, we're going to load in, finally, English Core Web Small. And we're going to load up our named entity client with that spaCy model. Then when we come down here, we call request.getJSON. we're going to set a result equal to ner.getInts, which is our way of proxying the sentence to spaCy in this case. We're going to pass it the sentence on that data dictionary. Then our response will be whatever the shape of the response we'd like to be for our front end. And our front end is actually expecting entities. And so we pass that back, and it's expecting HTML. And so we pass that back. Okay, and then we're just going to dump the response using JSON and return this. So let's go back to test API and run our test again. Okay, so we're getting a key error on entities. So let's go back to app.py, and we have a typo here. Again, another great thing that unit tests can catch for us. Oops, and here we called this ints actually. Okay, so let's go back to test API, and we'll run our test again, and we'll fix this typo here. So length of data entities is greater than 0, and we'll run our test, and we get a passing test. We can also make an assertion that Kamala Harris is the named entity that we get back here. So maybe we do something like assert data.entities dot zeroth in the index dot ent is equal to Kamala Harris, and we can assert that the label is a person. So this is sort of an integration test. We can see if it succeeds. And it does. So now you can see just another way that we can continue to drive our work, in this case using more of an integration test and actually using this test client sort of fixture that's provided by Flask in order to make post requests against some endpoint. And if we've done everything correctly, then we can see that all 15 tests that we wrote throughout this TDD session are passing, and we've done a mixture of unit tests here, some end-to-end browser automation tests, and an integration test on the API. So thanks for watching, and I hope you enjoyed the series.